Welcome back to Calculus 1. We're looking at question number 17 from homework number 4, part 2. The solution to this problem is that the f of x values have to be between 1.99 and 2.01 exclusively.
So in this problem we have a function, f of x, and we're saying that the values for f of x are real numbers. All that means is that the function, for example, the function maybe is f of x equals x squared. What we're saying is that regardless of what x we plug in, for all the x's in the domain of f, maybe like 3, f of 3 comes out to be 9, which is a real number. So what we're just saying is that every time we plug in an x, the value that comes out is a real number. Okay, so there's nothing special there. So remember that these guys right here, these guys are actual numbers. Okay, so you treat them like a number. Now what we need to determine is f of x minus the value 2 is strictly less than 0.01. So what this says is that the distance between all f of x values and 2 is strictly less than 0.01. So on a number line, I'm going to look at this vertically just so that it helps you out thinking about function values. But it's the same idea, I'm just turning the number line sideways. Here's the number 2, okay, and here's 0.01. So if I go 0.01, I would come up here. Let me put my borders. So this is going to be 1.99 and 2.01. That gives me a distance of 0.01. Okay, that's this guy right here. So I need the distances to be less than that. So f of x has got to be stuck between these two green lines. So f of x is somewhere in there. Okay, so it's either in this side or it's in this side. It can't be equal to these green lines because we have it strictly less than. So it's stuck in there somewhere. Now how do I write that interval? I would say that f of x is less than 1.99 and it's greater than 1.99 and it's less than 2.01. Okay, this is your solution right here. Okay, now there's another way to get it. Obviously we don't have to draw this out. We can just take a look at this original equation just like that, and we can use our properties for absolute values. So one of them says is that if this guy is positive, now when would it be positive? Well, it would be positive when f of x is larger than 2, meaning this side right here. So if f of x, remember f of x can fall anywhere it wants in here, okay? If it fell on this side, then the absolute value of f of x minus 2 is just going to be equal to f of x minus 2 without the absolute values. So we want that to be less than 0.01. The other option is that the guy on the inside here, okay, this guy on the inside is negative, meaning that it would be over here. So think about it. Over here, if you grabbed an f of x value, okay, right in here, and you took any number in here and subtracted 2, it would be a negative number because these guys are all smaller than 2. So it would have to be, this would have to be negative. So if this is negative, okay, then to get rid of the absolute values, we have to put a negative on the outside. Okay. So now we've split this into two separate cases. Case number 1, where it's positive, and case number 2 being where it's negative. So now we got to solve both of these. And when we solve both of these, we're going to end up back here. Okay, so let's go ahead and check that out. This is going to be f of x. If I add 2 to both sides, that tells me f of x has to be less than 2.01. Right here, and that's this part of it right here. If we solve this, if we multiply both sides by -1, we get this. We get f of x minus 2 is greater than negative 0.01. And if we add 2 to both sides again, we get 1.99 and f of x. So this one says that the function values have to be greater than 1.99. That's this part right here. And if you put both these two together, you get this whole thing.